Hello. So continuing our work in area and volume, we're going to be looking at the area and volume of a cylinder today. So a cylinder is just a name for the same shape as a bean tin. So we have, if you imagine your bean tin or your soup tin, you have a circle on the top, you have a curved bit as the walls of the tin, and then you would have a circle on the bottom that we can't see underneath here. So we have a circle on the top, a curved part, and then a circle on the bottom, and that's how we make up our shape of our bean tin. Now the volume of that shape is going to be pi r squared multiplied by h. You can see pi r squared, we ought to be able to remember, is the area of our circle. So if we got the area of the end and then multiplied it by the length of our shape, which in this case is h, we get the volume of our shape. So this links back to what we were doing the last day in terms of the area and volume of our prisms. So we have the area of the end is the equation of the area of our circle multiplied by the length of our prism. So this is another example of the same type of stuff as you were doing the last day. Now, looking at the surface area of our shape, the surface area means exactly what the English would indicate that it means. It's the area of the different surfaces of our shape. So the top of our bean tin is a circle. So we have the top and the bottom are the area of our circle. We have two of them, one for the top, one for the bottom. So the area of the top plus the area of the bottom is our two areas of the ends here. And then this bit is the equation for the curved surface area. So in some questions they will ask you about the total surface area, as I've given it to you here. In some questions they will talk about a curved surface area. That's just the wall of the bean tin, and that is going to be 2 multiplied by pi multiplied by r multiplied by the height of our cylinder. So we need to know what both of them mean. Total surface area is all of this, and curved surface area would just mean the wall of our bean tin, so this formula here. So those are the different pieces that we need, and we're going to have a look at question 1 part 1 and question 2 part 1 on page 253. So using the pi key on your calculator to find the volume of each of these cylinders, give your answer in centimeters cubed correct to the 1 decimal place. So I've drawn out a sketch, as I always do for my questions. I draw out a sketch of my situation, and I've labelled in the radius of my cylinder is going to be 5 centimeters. That's given to me in the picture, and the height of my cylinder is going to be 9 centimeters. Again, that's given to me in the picture. And I'm asked to find the volume of my cylinder. So if I hear volume of a cylinder in an exam question, I'm going to write down pi r squared h, and this is in your log tables. This is one of the formulas that you have in your log tables. So if we look what information we need here, we need to know r and we need to know h. Well, in this question we already know them. We have r is 5 centimeters and we have h is 9 centimeters. And that's everything that we need. Pi is just a button on our calculator, and v is what we're looking for. So v is equal to question mark. So now sub into my formulas. I have v is equal to pi multiplied by r squared. Anywhere I have an r, I'm going to put the number 5 squared multiplied by 9 for our height. Anywhere I have a h, I'm going to put 9 in brackets. Anytime I'm subbing anything in, I always put it in brackets. Now when I put that into my calculator, I get 706.858 and so on. And in this question it asks me to give my answer to 1 decimal place, so I'm going to round this to 706.9, and I remember that my units for volume are cubed. So for area it's squared, and for volume it's cubed, and for length it would just be centimeters. So this is my final answer as I've been asked to give it in my book. Now if we look at question 2, it asks us to take the same shape. So I have my same sketch here. I still know that r is equal to 5 centimeters and my height is equal to 9 centimeters. Again, in question 2 part 1 it tells you you have the same shape as in question 1 part one, but now we're looking for the total surface area. So if I hear total surface area, I'm going to remember that I have this formula here. The curved surface area is a formula given to you in the book. This complete formula is not given to you in the book. You would have to draw a sketch and remember that you know the curved surface area is equal to this, which is in your log tables, and you know that the two ends are two circles, so I'd use the formula for the area of a disk or a circle. Now, so total surface area, I'm going to write down my formula, is equal to 2 pi or h plus 2 of my end circles. And I now have a formula, and I can see that I have everything that I need to put into that formula. So I'm going to have 2 multiplied by pi multiplied by, or is 5, h is 9, plus 2 times, because I have the top and the bottom, that's why I have a 2 here, 2 times the area of the circle that makes up the top and the bottom of my cylinder. So pi multiplied by or is 5, and anytime I sub in, everything goes in brackets. And I put this into my calculator exactly as I have written it here, being careful of where I put my powers. And when I put that into my calculator, I get 439.823. And in this case, it asks us to give each answer correct to the nearest whole number. So for my final answer, I'm going to have to give correct to the nearest whole number, and I see that I'm going to have to round up, so this is going to end up being 440 centimeters, and this is an area, so it's going to be squared. So I have to be careful with my units in these questions that I keep track of whether I'm dealing with volume or area. And those are the formulas that we need today.